In this section, we're looking at a popular process in algebra called simplifying. Take a look at this expression here. Would you believe this expression is equal to that? This is what simplifying does. Think of it as cleaning up a mess full of math clutter. Simplifying brings the expression to its most basic form, as in now it's simple and squeaky clean. Why is simplifying done? To make life easier, of course. I don't know about you, but I'd much rather solve using 2x plus 1 versus all of that over there. So how do we simplify? The easiest process in simplifying is called combining like terms. Remember, terms are parts of the expression separated by a plus or minus sign. All you're doing is adding or subtracting terms that are similar. Now, what makes terms similar or quote-unquote alike? 1. They have the same variable and exponents. So as we see with the long expression, the terms that have the variable x are the like terms, because that's the letter they share in common. 2. The terms that are just constants are like terms because they are just single numbers by themselves. The best thing to do when you find like terms is to group them together. Now, when rearranging an expression, the plus or minus sign that is in front of the term goes with it. So let's group them. 5x minus 4x plus 3x minus 2x. We've gathered all the terms with x variables. Now we can group the single numbers. Plus 3, plus 1, plus 2, minus 5. All the like terms are now grouped together. When you add and subtract them, you get the simplified version, which is 2x plus 1. All right, we're going to look at the long expression again. This time we'll change minus 4x into minus 4y and simplify. When grouping the expression, you'll notice minus 4y has no term to combine with because of the y variable. Therefore, minus 4y just stays as it is. The terms with x variables are still grouped together. So that's plus 5x plus 3x minus 2x. And now we group the single constants. That's plus 3 plus 1 plus 2 minus 5. Add and subtract the like terms to get the simplified version, which is minus 4y plus 6x plus 1. Now be aware that either of these expressions are the exact same thing, but the terms in different order. So don't be confused if you sometimes see terms rearranged differently. Now let's make things a little more interesting. This time I'll turn minus 4x into minus 4x squared. Now that x is squared, what do you think happens? If you guessed combining minus 4x squared with the other x variables, you'd be wrong. Now you might be saying, but minus 4x squared still has the same x letter. Yes, that is true, but they have different exponents. Even if terms have the same letter, if the exponent is not the same, then you cannot see them as like terms. Use your imagination and think of it this way. Like terms are family members in algebra. They are related and they look similar. Having the same letter means terms quote-unquote look alike. And the unknown variable of those terms having the same exponent means they're quote-unquote related. So check this out. Let's apply this family idea to these examples here. When terms are in the same quote-unquote family, they are like terms and they can be added and subtracted together. With x plus 2x, both terms have their letter x as their unknown variable. Also, both letters have the same exponent, which is 1. Any number to the power of 1 is itself. Therefore, the number 1 stays invisible. Since x plus 2x have variables with the same letter and exponents, that means they are like terms. So when simplified, x plus 2x is equal to 3x. With x squared plus 2x, both terms have the same letter x, but this time they do not have the same exponent. Therefore, they are not like terms. Think of it this way. Just because someone looks like you doesn't mean they are family members. So this means x squared plus 2x simplified stays the same. Alright, now we're looking at x squared plus 2x squared. Both terms have the same letter and exponent. Therefore, these are like terms and can be added together to simplify. So x squared plus 2x squared becomes 3x squared. This expression, x plus 2y, shows terms that have the same variable exponents of 1, but they have different variable letters. The terms are quote-unquote related by exponents, but in algebra, they must have the same letter to be considered like terms and added. Therefore, x plus 2y simplified stays the same. Lastly, with x minus 2y squared, we can see that both terms have a different variable letter and both letters have a different exponent. Therefore, these are not like terms. They don't look alike and they're not related. So when simplified, the expression x minus 2y squared stays the same. And that's how identifying like terms works. Okay, now let's revisit this expression to which I changed minus 4x into minus 4x squared. Let's group the like terms and simplify. We have minus 4x squared. There are no like terms for it to group with. We group the x variable terms and then we group the constants. Now add and subtract the like terms to get a simplified expression, minus 4x squared plus 6x plus 1. Here's a quick note to remember. In algebra, the term with the highest variable exponent is almost always written first, and the constant is written last. This standard just prevents confusion, but if the terms were in different order, the answer would still be correct. And there you have it. This is how you combine like terms to simplify algebraic expressions. In conclusion, like terms with unknown variables have the same letter and the same exponent. Constant terms are simply added or subtracted together because they are just single numbers. Well, that's a wrap. Now get to studying.